Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X, Planets, Stars, and Black Holes. Now, Planet X refers to a system of dead stars and planets which have invaded the solar system and which I also refer to as stellar cores. They are destructive, but they have a lot to teach us about how the universe really operates. And here we see a CME, or a release of coronal plasma by the sun. And it looks like extremely hot and glowing liquid plasma spewing out into space. Now, the sun, as I have explained in the second part of the series of articles on planetary climate change, has solar flares and CMEs, which result from the interaction between the stellar cores and itself. The interaction is an energy drawing process which affects the gravity of the objects. A drop in energy causes an object's gravity to drop, whilst an increase in energy will cause its gravity to increase. So the stellar cores gain gravity and the sun loses gravity. As the stellar cores absorb energy from the sun, it is less able to pull its outer plasma layer or inner corona inwards. So when the stellar core comes into the sun's corona and draws energy, thus causing the surface under the stellar core to become hotter and the electric field to increase at that point, a solar flare or CME sometimes occurs. As the sun becomes weaker, these provoked solar flares and CMEs become stronger and larger in relation to the size of the stellar core provoking it. And what actually occurs is illustrated here. If we have a hot object and a cold object, we know that heat flows from the hot object to the cold object. Well, in the same way, heat flows from the sun to the stellar core because the stellar core is depleted in energy and the sun still has a reservoir of energy, still able to generate energy that will flow out from its core through its layers to the surface of the sun and out through the connection that the stellar cores actually make with the sun by drawing matter from the sun towards themselves. But this causes heat to come from inside the sun out through the sun's layers, and it will cause increased heat at the surface of the sun and therefore an increased electric field at that point, which then makes a solar flare or CME or energetic solar event more likely to occur at that point. And so these solar flares and CMEs occur because the sun is capable of generating enough energy in order to produce these. The sun is still generating the energy that is producing it, even though the stellar core is provoking it. Now, the sun is an extremely large object, and its internal energy allows it to generate a very intense electric field in its outer layers. This electric field allows it to ionize its atmosphere to the point that it is plasma in arc mode, and it allows it to accelerate this plasma to the point that it is released out into space as solar wind or as CMEs. Planets, at least small rocky planets, like the Earth, are not likely to have a large enough core to generate the same energy as a star, so are not likely to be able to produce solar wind or CMEs. The Earth, because it is so much smaller, about 100 times smaller than the sun, is not likely to be able to generate enough energy to produce an electric field strong enough to produce CMEs. So it's all about the size of the object. The Earth is so much smaller than the sun that it cannot actually operate like the sun does as a star, because it just does not have a large enough reservoir to generate a large enough electric field to produce plasma in arc mode like the sun does. You can see here how small the Earth is in comparison with the whole sun. It's just like a little speck. But the Earth is losing energy, and it's losing energy to the stellar cores, and the stellar cores which are energy bound to it, will be increasing in energy. So they will be able to draw matter from the Earth with more and more ease. And there will come a time when the Earth will be shedding its layers of matter. These releases of matter into space will not be explosive events like CMEs, though. The matter will just move out from the Earth and float around the Earth as it was doing around the blue stellar core when Scott photographed it through his telescope. And here we see one of these photographs that Scott took through his telescope last year of this blue object. And this object was shedding its outer layers of material, and this material was forming these stripes that the object had. Now, the object was 1/3 of the size of the Sun, so over 3 times larger than Jupiter. And a cloud of material is seen here coming from the object, and solid pieces are seen as well. Some solid pieces. Obviously, it sheds material in the form of dust and in the form of some very small pieces. But obviously, this material is all in the solid phase. Now, the object seems to have absorbed enough energy from the Sun to be able to emit this blue visible light from the surface of its core. But it most likely has no reservoir of unstable nuclei left. Only photon energy it has directly absorbed from the Sun. So it will never be a living object again, and it will remain dependent on the Sun for its photon fuel. And it will most likely, as it absorbs more energy, become brighter. I have written articles where I show that these objects become brighter to the point they become white hot again, like the Earth's core is expected to be white hot and solid. Now, these show a stellar core making its matter connection with the Sun. As you can see, they draw matter from the Sun, so they make this root-like connection with the Sun, and plasma from the Sun is being drawn from the Sun towards the stellar core. And through this drawing of material, they eventually gather enough material around the core to have an atmosphere of coronal plasma. And they start emitting light from that atmosphere. They also emit light from the connection itself. And the stellar cores that are energy bound to the Earth, that have been captured by the Earth, will do the same thing with the Earth's atmosphere. And they will make these connections with the Earth. They will draw material from the Earth. And then this material will be ionized. There will be a high electric field, not enough to cause ejection, great acceleration of particles, but high enough for radiation to be emitted from both the atmosphere of the object and from the connection itself. And this then may be the reason why such high radiation is now reaching the Earth's surface. Now, one way to differentiate planets from stars is that stars are able to greatly accelerate matter in their atmosphere and thus eject it, which can be viewed as the production of solar wind. A CME is simply a solar wind ejection which is larger than normal and coming from one small region in the star's atmosphere. But the ejection of matter or solar wind production causes the formation of rings or nebula clouds, which then gives stars a planetary nebula structure centered on the star, and this is what we see here. So these are nebula clouds produced by the star itself, which is at the center of the clouds. And this is produced due to the star's own solar wind. It ejects matter outwards from the star itself. So, and you may look at article 254 entitled Planetary Nebula and Death of a Star for more details on that. Smaller and less powerful stars produce smaller ring patterns. The fact that both Jupiter and Saturn have rings indicates that they are small stars, not planets, but an object with no nebula clouds and no ring structure like the Earth would then be classified as a planet. And here we see Saturn. It produces a ring pattern, so that means that it is able to eject matter outwards away from its atmosphere, and is therefore a star, a small star, because the ring pattern is very small. In the case of the Sun, the Sun's nebula clouds will go out to beyond Jupiter, so that means that the Sun is a strong, very powerful star, but Saturn is a small star, and so it produces a ring pattern very close to its atmosphere. But the stellar cores are difficult to classify. They have no ring pattern or nebula clouds, or these concentric clouds, but they seem to always be enveloped in a cloud of material, either because they are shedding material or they are gathering material. But it should be safe to assume that the largest ones were once stars and the very small ones were once planets. One of the most important things they show us is that planets and stars are not that different, as they both have solid cores and are powered by the energy stored in those cores. They also show that gravitational collapse does not occur. If it did, the largest stellar cores would have turned into neutron stars and black holes long ago. Thus, the fact that stars turn into stellar cores when they die shows us that black holes do not exist. And most important of all, they show us that an object's gravity is dependent on its internal energy. That means I have called it photon energy. It is due to photons, and I have called it gravitational energy because it is connected to the gravity of an object. And the stellar cores actually show us that as an object ages, it loses energy, its gravity decreases. So instead of gravitational collapse, we have the opposite. The gravity of an object decreases. In conclusion, stellar cores have much to teach us about the universe. They show us that stars and planets are very similar, and show us that gravitational collapse does not occur. Black holes do not exist, and the gravity of an object is dependent on its energy. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.